Can you talk a little bit about prediction, projection, and forecasting, things like the turnaround of the economy?
Well, yes. There are a number of areas that still interest me in the area of prediction. One of the earliest applications of AHP in prediction was presidential elections. We always predicted who's going to be the next candidate and who's going to win, etc. Since 1976, when Carter was running, we predicted Carter would be elected. Then, when I moved to Pittsburgh, I had colleagues who are economists and said, why don't we use the AHP to predict when the economy goes into a slump, how long it's going to take for it to recover, and how strong the recovery is. So we've published now 4 articles since 1990 about U.S. economy turnaround, 1990, 2001, and 2008, the disaster, and some revision paper appeared in a Canadian journal because the Canadians thought they wanted to know more about the AHP. And in all these cases, our forecasts were very close to what actually happened. In fact, I have a record of the Wall Street Journal article written about a year and a half after, citing about it's the same as we had predicted. Although there's a National Bureau of Economic Forecast Research that deals with these matters, but I'm not sure that these people yet know about the use of judgment to measure intangibles. They ferret through a lot of data to make their decisions, but I think that, okay. So the next kind of field that I'm interested in is using AHP in sports to predict the outcome of sports events. Now, this has an interesting background. In probability theory, there's what's known as the Bayes theorem, that the probability of causes and effects. And as you look at it, it looks like a straightforward field, but it is used even in medicine. The problem is that if you have an effect, which cause is most likely to have brought it about? If you have fever, it can be caused by many diseases. And so it's hard to converge unless you know more about that kind of fever from the person. 3 or 4 doctors, I don't remember, from Youngstown, Ohio, came to see me here a number of years ago and said, oh, we have a problem, we're being sued, and we may be put out of business by a patient's family. The patient had reported in with stomach trouble. They gave him 2 tests and then used Bayes theory and concluded that he had cancer. And they took out his stomach and he died. They said when we looked at his stomach, there was nothing there that Tums wouldn't have cured. And so we talked about the need to ask the patient questions and not just to go on Bayes theory, on statistics. So now in sports, people use a lot of statistics, that's all they have, but they don't use judgment on the kind of players, their excellence, blah, blah, many factors. And so I have written a paper with a visiting Chinese scholar about how to combine Bayes theory with judgments, and it becomes an eigenvalue problem to improve prediction. And my colleague assures me, he has analyzed basketball in detail there, that he can make predictions of about 75 to 80% of the time right. And then another visiting scholar decided to apply it in hockey. And he just yesterday morning sent me the results on hockey, and he marked where he was not right he was right most of the time, using judgment about the players and how they're meshed and so on. I don't have the whole detail now, but that so there are these possibilities. Yeah, after all, human judgment, the human mind is paramount, and after much study and refinement and so on, the mind should be able to handle complexity better than just relying on data and statistics, although that's important, and that's what we're trying to do.